My name is Daniel Sobek, CEO of Day-1s1 Energy. Our company is developing next generation proton exchange electrolyzers for the production of green hydrogen. I have worked on many deep tech startups since I left MIT, but none as exciting and consequential as Day-1s1. In the next 8 years, the electrolyzer installed base is expected to grow at least 200-fold. To meet this expected demand, incumbents are rapidly scaling existing technologies, taking advantage of automation and economies of scale to reduce capex. At the same time, we believe that they are making a strategic mistake by freezing in efficiency and durability of current systems, thus jeopardizing robustness as they scale up electrochemical area. New entrants are mostly focusing on new engineering approaches, such as producing hydrogen sequentially, reducing mass transport issues created by gas bubbles, or using very thin proton exchange membranes. The elephant in the room is that without serious material innovation, green hydrogen is unlikely to be economically viable. Our goal is to produce green hydrogen at a levelized cost below $2 per kilogram. We believe that proton exchange technology has the best fundamentals to reach this target within 5 to 10 years. Therefore, we're working on novel proton exchange membranes, catalyst layers, and internal coatings to improve the electrolyzers to achieve this goal. We're designing our systems for robustness, manufacturability, and serviceability. Additionally, vertical integration allows us to remove margins from components, reducing capex. Our early customers had interest in using our electrochemical cell materials to implement catalyst-coated membranes for fuel cells, which is a more mature market. Through collaborations with these customers, and you see Merced, we noticed that our materials work well under dry conditions, particularly using low catalyst loadings, which has been a limitation of standard materials. These innovations will increase the power density and durability of fuel cells while using low amounts of catalyst group metals. We are now applying these innovations to water electrolysis systems and designing innovative and robust internal coatings for electrolyzers. Already, our technology has been validated by several partners and recognized by the European Commission's approval of Day-1s1's 63 million high-to-tech important projects of common European interest. We have identified several areas for partnerships with companies working on fuel cells or interested in producing green hydrogen. We're interested in collaborating on the production of reinforced or high-temperature ion exchange membranes for fuel cells using our novel ionomers. There's also an opportunity to help us refine our catalyst supports to further reduce platinum group metal loadings in fuel cells. On the electrolyzer side, we wish to collaborate on electrolysis stack pilots as we incrementally transition from 5 kilowatt stacks all the way up to 1 megawatt modules. Thank you for your attention, and I look forward to your questions.
Great, Dan, thank you. So what would you say is novel about your membranes and layers and coatings?
Yes, in terms of the membranes, we're using a new type of acid group that is intrinsically ionic, and that allows us to have greater efficiency, durability, and also operate at higher temperatures. And in terms of catalysts, we have developed new catalyst supports that allows us to work with lower amounts of catalyst.
Great. And what are some ways in which you work with corporates, or what are some fields or industries that you think are best at this stage?
Yeah, so we're already working with fuel cell manufacturers of memory electrode assemblies. We're sampling materials, and also we're entering into formal collaborations. We also have a large utility that is testing our stacks.